morning. Welcome to episode number 32 of the ZOOMTOWN experiment. For today's episode, we're going to focus on creating traffic control devices within the layout. Well, not necessarily within the layout. Today we're just focusing on the zoomy portion so it can see those traffic control devices. For our situation, I think the only traffic control device we need is a stop sign. There are certain intersections within ZOOMTOWN where I want the zoomy to stop before proceeding. There's a few intersections that don't need to be controlled. They're free-flowing, so we won't be bothering with putting stop signs there. Now, for our stop signs, what they really consist of is a tiny little magnet. They're about 5 millimeters in diameter, a couple millimeters thick. In our world here in the United States, it'd be about 3/16 to a 1/4 inch in diameter, right in that range, and about 1/16 to an 1/8 inch thick. To position the magnet on the layout as accurately as I can, I used this guy, which you might recognize as the front-mounted sensor bracket. This was our time of flight that we talked about last week. These two locations are where the Hall effect sensor goes. I'll try to get that to focus, probably won't. But nonetheless, I just laid that on the layout, positioned it where I wanted it, marked the whole location. Then I took a drill, drilled a hole in it. Then, frankly, the harder part was I had to put the zoomy on a side and then write a simple for loop to look at that sensor and see if it can detect a magnet when I would present the magnet to the sensor. The magnet has to be in the correct orientation regarding pole, either north pole up or south pole up. I'm not exactly sure which. I just test it with presenting the magnet to it. Then I position that in the hole and then put a piece of tape over it and a red dot so that we know that that's a stop sign. Not a whole lot of technical craziness there, just simple little tasks. Incorporating the ability to stop is a little bit more involved, but first let's take a look at a demonstration of it. We'll go to the overhead cam, we'll run the cycle. Now this spot right here is where that magnet is, as you saw in the video earlier, and it's below the surface, so it's flat here. There's nothing to hit it. I put a marker here so we can keep an eye on it. I'll go ahead and run the program. We'll see how it behaves. And with that, it stopped right where we wanted it. Now, how I'm doing that is a little bit on the tricky side, but it turns out it was easier to incorporate into the system than I thought it was initially. To do that, let's take a look at the code to see how all of this works. The first thing we want to understand is the electrical interface. And that is incredibly simple. We have two Hall effect sensors on the bottom of the zoomy. One I'm calling left Hall, the other right Hall. Right Hall is the one we're going to use with the stop sign. That's connected to pin 6. It is a digital input, and we're using the internal pull-up resistor, so I didn't need to add any additional electrical components such as a physical pull-up resistor. So all we're really going to do is look at the state of that switch to see if it sees a stop sign, which in our case is a magnet. Now we will scroll down into this area. This is in our auto adjust velocity routine, our powerhouse that does everything. In here is this is the check cast routine. Right below that, we just covered the check cast last week. Right below that is where I'm going to work on triggering or activating the stop cycle to occur. We want motion to stop. We know we have to decelerate, so I can't just simply say stop it and then we would watch the zoomy tip over, and well, that'd be kind of funny, but we want a little more graceful stop than that. In the code, we're just going to look for the right Hall value, meaning I'm looking at that digital input for the right Hall effect sensor. 0 is the setting when it's actually over a magnet. So 0 is what we're looking for to perform some action. And in our case for the demonstration, we're printing out the word stop and then printing out the distance to go. We'll explain that in a minute. Obviously, that's not needed for the function to work. It's just there to help explain it. And then we're going to calculate or recalculate our left distance to travel and right distance to travel variables. Now, those were assigned at the beginning of the motion. The Zoomy was told to say move 10 inches. And at some point near that 10 inches will be the stop sign, and we wanted to start stopping at that point and then decelerate to a complete stop. So we've got that graceful termination of motion. To recalculate these values, we're going to look at the current left position and then add 1.25 inches. Metric, that'd be about 30 millimeters. And that gives it enough distance to coast to a stop. So, to get a perspective here, let's say I wanted to stop at 10 inches. My stop sign would be at 8.75 inches. We would see the stop sign, and then I can safely decelerate down to 0 speed at exactly 10 inches. So that's the math in there, and you'll notice I've got this hard-coded right now. Ultimately, that will be a variable because I still haven't worked out all the velocities, and as you can imagine, the higher the velocity, the longer the acceleration and deceleration distances are. And I'm not sure of how all that's going to interact and play out once we get into the actual ZOOMTOWN layout. So for right now, I'm just encoding it as essentially 30 millimeters or 1.25 inches. So that's all that is required to cause the Zoomy to stop and terminate that current motion. So again, we'll watch it run. Back it up. Okay, we'll let it run. And from here to here is about 1.25 inches. So that gives us our stopping distance as we were alerted by the stop sign. Now let's take a look at the output from this. And here's all of our goes that we're printing when it doesn't see a magnet. Right here is the point right before the magnet. This is the first occurrence of the magnet. It still has 4 inches to go, but we're stopping it short. And on the second time through that 5 millisecond deterministic loop, it resets our distance to travel down to 1.2 inches. And it'll keep doing that until it gets off the magnet, which is right after this line. And now it's off the magnet. So from that point going forward, it's going to move another 1.2 inches, give or take a tiny amount. So we'll take one more look at that and we'll wrap up this video. Oddly, I think that one went a little bit further, but let's see what we see in the data. Still looks like it was pretty right, so probably a little bit of tweaking on that deceleration distance. I think this is where we'll wrap up our Hall effect sensor being used as a stop sign detector for the ZOOMTOWN experiment. Now, I have been experiencing an unusual memory problem. I'm going to call it a memory problem. That'll make more sense, but it has to do with delays in the deterministic loop. And it was a very fascinating journey digging into that. And I think that's what we're going to cover in next week's video. So that'll wrap it up. Thanks for watching, and I look forward to seeing you next week.